Hello, good people. Welcome to this episode. In this video, we're going to learn something new that is going to prepare us to transition into using the high-level APIs of PyTorch. Before we start with today's video, I want to share with you where we left off as far as our series on PyTorch is concerned. So the last two videos were used for practical hands-on sessions where we learned how to build a spell checker and also how to um, take actions using the multi-armed bandit algorithm. And now this episode is going to continue our series on PyTorch. And so this is where we left off in our last episode on PyTorch. And what we did here was to build a linear regression model. And as you can see, we had to manage a lot of stuff on our own, like initializing our parameters, which is the weight and the bias. We had to take care of it. And I mean, this was a very simple example, so we didn't have to care about the shape and the sizes, but in bigger problems, the shapes and sizes becomes a lot of headache for you to deal with. So we had to manually create them. We also had to manually define a method for performing the linear transformation. We also had to manually define our mean squared error. And most importantly, when it comes to the training loop, we also had to manually take care of nudging the weight and the bias in the direction of the gradient so that we find the minimum point on the loss curve. Yes, these are the low-level APIs in PyTorch, and they are very useful when you want to do some custom model implementations and also use PyTorch for anything apart from deep learning practices. But then, because PyTorch is mainly used for building neural networks in production and in industry, there is also the high-level API called torch.nn. And what torch.nn does is to help us to build neural networks easily. And so the management of the shapes and sizes and even the training loop becomes a bit easier for us to implement. So that is what we are aiming to get towards. And before we start using the torch.nn library, there is two concepts in PyTorch that is important for you to understand. And so I'm going to use this video to explain to you what Dataset and DataLoaders are, and we can start using that torch.nn library. So like I have stated multiple times, the PyTorch documentation is a very good source of information, and that is where you get all the details. So if you want a lot of information about what I'm going to show you today, then you definitely want to read this Writing Custom Dataset and DataLoaders and Transforms in PyTorch. But today, I'm going to show you how to deal with datasets and DataLoaders in a very simple and approachable manner. So majority of the time, you as a deep learning practitioner is going to spend a lot of time creating or cleaning or collecting data sets, because the thing that makes deep learning works is availability of data, and it's not just any data, it should be clean data. So you will spend most of the time working on cleaning, collecting data sets, and merging data sets from different sources, and so PyTorch makes it very easy for us to manage our data sets through the dataset and the DataLoaders API. So let's start. I'm going to import Torch, and for today, all we need is the Torch API, the Torch module. So I'm importing Torch here, and what I'm going to do first of all is we want to learn about dataset. What does the dataset help us to do? Okay, there is a custom class called dataset which we can override whenever we want to implement our own custom dataset. But for today, I'm just going to show you a very simple already made dataset called TensorDataset. Okay, so for that, let's generate some features, and our features is going to be features. Okay, let me import numpy as well, because I want to use numpy. So import numpy as np. Okay, so now we have numpy and PyTorch, and then let's do from numpy. What I'm going to do here is I'm just going to do a range. This is similar to what we use for the linear regression session. So I'm going to generate numbers from -50 to 50, and I'm going to make the data type to be float 32, and always remember that this is mostly the default data type you want to set for the features, the data point in your features. Okay, now let's create our outputs, and I'm going to say output is equal to features times 9 divided by 5.0 plus 32. So basically I'm just simulating, I'm creating a data set that will help us to um, learn how to convert temperatures from degree Celsius to degree Fahrenheit. You have seen this before. That is not the object of this video. Okay, now we have these two data sets. Let's check their sizes or their shapes. So say features.shape, and let's print output.shape. Okay, if I do this, I see that I have 100 features in the, 100 data points in the features, and unsurprisingly 100 points in the output as well. Okay, now what the dataset class helps us to do, I would like to read something here. It says a lot of effort in solving any machine learning problem goes into preparing the data. PyTorch provides many tools to make data loading easy and hopefully to make your code more readable. So you know what the class exists for. Now we know that we have features and we have output, and you know that mostly to feed these into our neural networks, we need to feed them in pairs. So you take the first item on the features and you have to pair it with the first item on the output or the target, and you have to go to the second on the features and then the second on the target. Now without a proper way to manage it, the way we're going to do that is we have to manually say let's print features 0, let's get the 0th index, and then let's get the output 0. So this is how we mostly want to do our pairing, if not for what we are going to learn today. And so PyTorch makes available a class called TensorDataset, and this readily makes it possible for us to access the items from our features, our training data, the features in the training data and the target in the training data at a go. And so it helps us to access the corresponding element. It helps us to index it as though it was just a single tensor that we are dealing with. So I'm going to say data set, I'm going to call it DS. I'll say it's equal to torch.utils.data.tensor.dataset. Okay, and by the way, if you want to read about a data type or something that you are unaware of, what you want to do is in the Jupyter notebooks, I think you can do question mark and the name of the class, and it's going to print the doc string for that particular class. So this is for the tensor data set, and say each sample will be retrieved by indexing tensors along the first dimension. Okay, so let's create our data set, and what you need is you provide your features and your targets, which we have called as output in ours. Okay, now let's see how this then is useful. So now if I do ds 0, see what's happening here. It is giving me the first item in my features and the corresponding first item in the targets or the labels. Okay, in the same way, if I get, let's say, the fourth, you can see that it is giving me the fourth row in the features matrix and the fourth row in the output vector. Okay, in a similar way, we can also index it using lists. So let's say I want to get the first, the third, the fifth, and the seventh. Let's see what happens. So this is going to give us the corresponding items in the features and the output as found or as dictated by the indices that we have specified over here. So this is one way of using the data set. It helps you to readily access the rows in your features and the corresponding rows in your target. But this is not the coolest way to use the data set. So that is when the DataLoader class also comes in handy. And what the DataLoader class does is it helps us to fetch batches of items from our data set, and it supports things like shuffling, especially when we are dealing with proper implementation of stochastic gradient descent, where we have to shuffle our data before we do every epoch of training. So the way we create a data loader is, I'm going to say data loader is equal to torch.utils.data.DataLoader. So to create a data loader, you first of all need a data set which we have already created, and we can also say the batch size. You specify a batch size. Let's say we want to get it in batches of 5, and let's say shuffle is equal to true. So if I do this, I have a data loader which is an iterable that is going to return the items in the features and the output in batches. So I specify that I want in batches of 5. Okay, first of all, let's see how we can know information about what the data loader does. So like I showed you for the data set, you can also use just a question mark, paste it here and run it, and you should see what the data loader also does. So it says data loader, it combines a data set and a sampler and provides an iterable over that given data set. So we have this data loader here. How do we use it? Let me close this help window so we have a bigger screen. Okay, so how do we use the data loader that we have created? And like I mentioned, the data loader is an iterable, so you can loop over it using a for in loop. And because the data set, the DS here, is created such that when you index into it, you get items from the features and their corresponding output. Whenever we iterate over using the data loader, it is going to return n batches, in our case 5 batches of items in the data set. And because we set shuffle to true, it's going to shuffle the data set. I mean, it will randomly reposition things before it returns the batches, and this is useful when you want to correctly implement the stochastic gradient descent algorithm. For now, we just want to see how to use data set and data loader, so let's focus on that. Okay, so I want to say for x's, and then the x's is going to come from the features, and then the y's, which is going to come from the output in our data loader. Let's just print our x's and our y's, and then I will break. And the reason I want to break is because the data loader will loop over the entire data set, but now I just want to see one iteration of it. So let's run this and let's see what's going to happen here. So you can see that it gives me -45, -18, -2. So these are items in the features matrix. Okay, so these items came from the features vector that we created here, and the y's came from the output vector that we created here. But the good thing is that for every item in x's, the corresponding y you see is actually the corresponding item in the output vector. So basically, if I see 45, -45 in my vectors, on that same row, I will see -49 in my output. So basically, this is what I want you to know about the dataset and the data loader API of PyTorch. And it's important that you understand whatever is going on here, because we will use this in the next video when we start using the neural networks API of PyTorch. Okay, so let me just remove this break and then see how it's going to loop over. So you can see that for each iteration we get 5 elements from the features, and we get the 5 elements from the output, and like I want to reiterate that they are corresponding items found on the same row. Okay, so this is how to use the dataset and the data loader. Of course, you can always override the dataset class. I will also show you once we get to a point where it is needed, but for now I have just shown you how to use the tensor dataset to be able to use tensors or the datasets that you load from NumPy, and also use the data loader to load them in batches and also shuffle them. Of course, if I don't shuffle, if I say shuffle is false, and I think that is the default, if I set shuffle to false, then what's going to happen here is, let me break this. So what's going to happen here is, anytime I loop over, it is going to return items in the same order. So you can see that when I loop, it gets -50, -49, and then their corresponding items in the output array. But when I set this to true, it will actually randomize them before returning. So you see that now I'm getting 0, -7, and then 43, -7. So this is actually a useful thing to have when you are implementing stochastic gradient descent, which we'll talk about in the next video. So thank you very much for watching, and I'll see you in the next video.